Hello, everyone. This is Nayiri from Low Carb and Fasting. Now, my audience knows that when I invite a fellow type 1 diabetic, it's for my type 1 diabetics talk series. I'll put the playlist below so you can check it out. And we discuss type 1 diabetes. However, although today's guest is a fellow type 1 diabetes, we're going to discuss heart health. In fact, we're going to discuss chronic disease and with a focus on heart health. So our guest is a board-certified chiropractor and functional medicine practitioner. He holds a bachelor's degree in health and wellness and a doctorate in chiropractic medicine. He also has a master's degree in human nutrition and functional medicine. He's a public speaker. He's also the author of a number of books, the most recent of which is Understanding the Heart. Dr. Stephen Hussey, welcome to Low Carb and Fasting.
It's good to be here. Thanks for having me.
Dr. Hussey, I just finished, in fact, just a couple of days ago, I finished reading your book. And it was one of those books that I could not put down. Usually when you read a medical book, you go back and forth, you read a chapter and then it gets a bit too much. And then you get back and revisit that chapter and start taking notes. Your book has a beautiful flow to it, and it's suitable for the layperson as well as for anyone in the scientific or medical community. So I thoroughly enjoyed reading the book. I can't hold it up, people, to show you the book because my version, because I have the Kindle version. However, I will put the book link below, and I highly recommend that you go and buy the book to understand general health and particularly heart health. Stephen, let's start with how you started the book. You started the book with the biggest life-changing event that unfortunately happened to you when you were least expecting it, when you were not expecting it at all, I can say. Would you like to relay that to our audience, and we'll take it from there?
Yeah. So yeah, most of my adult life, I've been pretty passionate about health and trying to be the healthiest I can be. Being diagnosed at 9 years old with type 1, I'm predisposed to a lot of different conditions, particularly heart disease. And so I spent a lot of time, researching and trying to figure out how to prevent or how to create health, And yeah, to my surprise, I'd gotten higher and higher levels of health based on all my lifestyle changes. And to my surprise, I was 34 years old and I had a heart attack, a widowmaker heart attack. So a very serious heart attack, of which only 12% of people who have those types of heart attacks outside of a hospital survive. So I was one of those 12%. And so, yeah, it was quite shocking. And all this information that I had and that I was, trying to put into practice was, obviously good for me. But, it goes to show that these traditional paths to health and these traditional ways of tracking health are not the end all be all, because they are not a true assessment or they don't cover all the bases as far as what we should be doing to achieve health. And so, all the information I had beforehand was very important. I can't say that I was implementing all of them to the best of my ability. And I went through some very stressful times, that were somewhat out of my control just prior to the heart attack. And so, I've gone pretty deep in the research into figuring out why I think this happened to me, because when I was in the hospital, they gave me very bad answers, very inadequate answers, in my opinion. Because they were trained to, do a certain thing after someone had a heart attack. And so, I've as much as I knew before it happened, I've learned so much since, a lot since, and it all falls in line with what I wrote. So in a way, it kind of reinforced what I wrote. And, at first I had the heart attack and I was like sitting there in the hospital bed and I was like, I'm a hypocrite. I was very down on myself. It was a low point for me, but then what happened in the hospital As far as my care after the fact, I mean, my care of saving me from the heart attack was obviously, I'm very grateful for that. I'm thankful for modern science and modern medicine in an emergency situation. Very, very useful. But after the fact, as far as like what they told me to do was the complete wrong information based on the evidence, based on what actually creates health. And so it kind of re-inspired me just pretty quickly that the information that I had in the book is very, very relevant, and that people need to know it, because someone faced with that sort of situation and sitting there in the hospital, which will happen unfortunately to many more people, they need to be able to make educated decisions. And it's not to say that what I say to do in the book is right. It's just to say that you need all the information so that you can make educated decisions. Because how are you supposed to make a decision that's best for you if you don't have all the information? If all you have is the information you're getting from the caretakers in the hospital, how are you supposed to make the best decision for you going forward? And so I quickly regained my confidence and was like, people need to know this, especially with what I was experiencing in the hospital and their one-way approach to managing and preventing this again. And so yeah, I didn't take their advice or much of their advice at the hospital, and I went out home and I did my own thing, and I put together this regimen of healing my heart, and happy to say that my heart is 100% better. The conductive signal is completely healed. There's no signs of heart failure. The scarring of the heart is minimal to non-existent. So I'd say that I fared pretty well, not following their recommendations of all the medications and the type of diet they were recommending, which was terrible. So yeah, I mean, that experience happened to me, but it was pretty shocking and not ideal, but it has reinvigorated me in the end as far as spreading my message and helping people avoid that very situation, and helping people who are in that situation get out of it victorious.
Yeah, thank you for covering the current recommendations and the inadequacy of the current recommendations and the standard of care. You covered that, I think, right in the first chapter. I was surprised because they had an educated person in front of them asking questions. They weren't even open to answering the question. This is how it is. This is what you do. And they either didn't know any more than what they were recommending, or they didn't want to look further and investigate for you. It was just their way or your way. It's troublesome. It's troublesome reading that. Yeah, I was kind of troubled by that.
Yeah, so it was, all the things that I encountered in the hospital, whether it was the treatments, or all the medications pushed, or the type of diet, or what they wanted me to do going forward, all that was disappointing. But the most disappointing thing was the shutdown of conversation. As soon as I started questioning, or just, it wasn't even like doubting. I was just like thinking, well, why do you want me to do that? I was just trying to get information because, I valued their opinion. I wanted to know. I was going to make my own decision, but I want to know their opinion and why they want to do certain things. That's all information for me. But as soon as I started questioning it, they took it almost personal, and then they just shut down the conversation. So it just goes to show that in that setting, there's no one's really inspired to be curious, or they don't have time to be curious, or they just have no interest in being and figuring out what actually is going on. And if there's different ways, they don't have time to discuss that with me. They come in, they tell me what to do, and then they leave. And so there was just it was almost like I was threatening them just by asking questions, and I wasn't being argumentative. I was just like, well, what about this? Or what about the fact that this medication causes that, or whatever? And they were just like, well, this is what we do. They have a cookie cutter recipe of what they do for someone who has a heart attack, and this is what you do, and you don't ask questions. You go throughout your day. So that was the most disappointing thing, was a shutdown in conversation. So I hope that this book that I've written opens the conversation, because if we're really going to figure out what causes heart disease and what causes heart attacks, we need to open the conversation. That's the most important thing. We need to have open, honest discussion, and that's not happening, as I saw in the hospital, not happening at all. Because it's it's that open, honest conversation that gets us to the truth, because like, if you want to, you could say that I wasn't trying to be argumentative in the hospital, but sometimes it turned into little arguments, respectful arguments. And the point of an argument is not to win, it's to find the truth. And, the truth, at least, for both sides, where is the truth? And so when it becomes trying to win from one side or the other, then, the argument's never going to become productive. And so if you're obsessed with trying to win, which is they were telling me to do this, and if it wasn't their way, it was the highway. So, so it was trying to open the conversation and then not being open was the most disappointing to me.
When I was reading the book, I kept wondering what it would be like if it were me, with no understanding of heart health, obviously no prior knowledge, and with the system of care here in the UK. I'm in London. So I kept wondering if it would be different here, if they would be more open to discussions. And I've had no experience of that, fortunately. However, I have many other smaller experiences with my endocrinologist, with my GP, talking about low carb. And I know that they are not willing to look outside that narrow box. And so perhaps, if I were in your situation, it wouldn't be any different here in the UK either. So I did think about that. So let's start with the health part of the story now. So you do clearly say, and this is a quote from you, the breakdown in mitochondria results in chronic disease. And heart disease is, you classify it as chronic disease, right?
Yeah.
Okay, so let's start off with the mitochondria. What are the mitochondria, and why are they so important? And what happens so that they break down and then they get damaged, and that results in chronic disease? Let's just cover all that. I know it's quite broad because you explain that throughout the book.
Yeah. So mitochondria are the little organelles inside of our cells that are responsible for a lot of different things. It's thought, we're taught in biology classes and medical school that they are the powerhouses of the cell, and that their main job is to make ATP. And ATP is, kind of like the energy currency, or we're taught that it's the energy currency in our bodies that drives all cellular processes and functions. Now, that is mostly true. I would say what I just said is mostly true, but mitochondria are much more than that. And ATP is not necessarily, the currency of the cell. It's very important, but it's not necessarily what drives all cellular processes. So anyways, the mitochondria are the organelles that allow us to take energy from various sources, whether it's the chemical bonds in food that we break down, and we can get energy from that, or the sunlight, or correct electromagnetic fields, like contact with the earth, like taking energy from our environment in the form of electrons, or in the form of electricity, we should say. And it takes that electricity and it passes electrons down what's called the electron transport chain, and we end up making a lot of different things. We make carbon dioxide, which is why we have to breathe that out, right? We make water, and this is perfectly deuterium depleted structured water that it's making, which is very important. That's the type of water you want to be made. So we're taught in school, though, this water is a byproduct. It's like, oh yeah, that's just a side effect of what the mitochondria do. It's like, no, it's actually very important. It makes a free radical. So, a free radical is a molecule with an unpaired electron, which is quote unquote unstable. But these free radicals do a lot of different things for us. They actually trigger a lot of different cellular processes, and they can even help with communication between different aspects of the body. And then also, the mitochondria generate heat, which is why we're warm, heat creating beings, the heat in the form of infrared light. So that's why we actually emit light as humans, but it's in infrared, it's non-visible spectrum light. And that's why you can put on a pair of infrared heat goggles or thermal goggles, and you can detect somebody. And then also they make ATP. And so the ATP is the main role for ATP is to unfold proteins. So proteins become folded, and if you unfold them, they get more surface area. And these unfolded proteins in the cell are what allow the cell pretty much to function like it's supposed to and communicate to other cells. And the main role of ATP is to maintain this unfolded structure of the collagen proteins, the extracellular matrix in the cell, so that it can do what it needs to and communicate. So that's mitochondria. Now, going into heart disease, that mitochondria are very, very dense in heart cells. There's lots and lots of mitochondria. Just one of the heart tissue is one of the tissues with the highest amounts of mitochondria in the entire body. It's about 5,000 per cell, give or take. The eye is also very high in mitochondria, and the brain's pretty high too. But the heart seems to be the highest. And so it's very, very important to maintain health of our mitochondria. And so to maintain health of our mitochondria, we need to, avoid inflammation and oxidative stress. So that could be lots of different things that we could talk about, but also getting adequate energy from your environment. So sunlight and grounding and things like that, but also, the correct, the correct fuel source as far as food goes is important. We get about a third of our energy from food, and so it's important to have a fuel source that is, I'd say, more efficient. And so that is fatty acids and ketones. Those are much more efficient fuel sources for our mitochondria. They create less exhaust, I would say, less, if you're talking about like a car metaphor, but they create less free radicals. They're more efficient. You get way more ATP when you use fatty acids and ketones. So, and it's interesting, the heart actually prefers to burn fatty acids and ketones. Whereas most tissues in the body, like we all know in the low carb space, that we have to restrict carbohydrates to encourage the body to go over to burning more fatty acids and ketones, to making ketones and burning fatty acids. But with the heart, even in the presence of glucose, it will choose to burn fatty acids and ketones. And I think there's a reason for that. And that is because if heart tissue is forced to burn more glucose than it wants to, issues can happen. And that can lead to what I call metabolic heart attacks. And so there was this trade-off, whereas, heart cells couldn't divide, so they had to be very, very efficient because they can't divide and make new tissue. They have to be able to repair themselves, so they have to maintain that efficiency. And that was the preference for heart tissue, to burn fatty acids and ketones. So yeah, mitochondria all play a role in that, and they're very, very important for our health. Literally, they're what's driving our physiology. So yeah.
Yeah, I like that you mentioned that, because that was one of the quotes I actually picked out from the book, that most of our organs prefer to burn fat for fuel, but that's particularly true of our heart. So what damages the mitochondria? You did mention oxidative stress and inflammation.
Yeah. So
let's elaborate those, and what else damages the mitochondria?
Yeah. So we can't get a state where we have too much oxidative stress, too many free radicals around. And that can happen. There's evidence that shows that can be contributed to by having a processed food glucose burning metabolism, where you're burning too much glucose for fuel rather than fatty acids and ketones. It could also be a state where there's a lot of inflammation and oxidative stress from external things, from psychological stress or from toxin exposure, everything from plastics to heavy metals to, whatever, all these man-made chemicals that are out there can all act like inflammatory things that damage mitochondria and other tissues in the body. But a big thing with mitochondria and in creating their efficiency is maintaining what's called structured water in your body, because structured water it's a form of water that's not quite solid, not quite liquid. It's kind of a gel state. And most of the water in our body is in this state. So all the water in your cells, and even some of the water in the blood is this. But maintaining that gel-like state of water, that's why the ATP are so important, because they're unfolding proteins so that structured water can form on the lining of the proteins. That's why ATP is so critically important. Even though it's not like this energy currency driving cellular processes, but it does help maintain proper function in the cell because it unfolds the proteins, providing structured water to form on that. And so that's very important for the mitochondria because this fourth phase water is actually it's the right environment for the mitochondria to function in. Because if there's not fourth phase water there, then what can happen is if it becomes more liquid water, the fourth phase water is actually less, it's actually more dense, so it's more compact, right? And so then, if it becomes liquid water, it becomes more expansive, and so that stretches out what's called the electron transport chain. Mm-hmm. And if that stretches out too much, then the electrons can't get transported very well. They're supposed to jump down this electron transport chain, right? And so if it gets stretched out too much, it's kind of like the Super Mario video game. If I tried to jump and I didn't make it, they'd fall, right? And so that those electrons can't jump and make that transition. And so then all the end products of the mitochondria don't happen, right? So we don't get the water production. We don't get the CO2. We don't get the free radical. We don't get the ATP, right? We don't get the heat. And so it's that lost energy, that lost electrons that create excess energy that make us gain weight. Whereas if we make that more compact, we structure the water, then the electron transport chain works perfectly fine. So how do we structure water, right? The main way is infrared light. Mm-hmm. So you want to get infrared light on your body. So you want healthy mitochondria. It's all about light. So infrared light builds structured water the most, and blue light gets a bad rap because there's lots of artificial blue light in our environment today. But blue light is healthy for us if it comes in the context with all the other wavelengths and color temperatures of light. The problem is that on our screens and our phones and everything, it's just blue light. And so we're just getting blue light all the time, and we're getting it at the wrong times. And so that can really zap your mitochondria. That can really interfere with the water. Like I said, a proper metabolism and burning more efficient fuel sources like fatty acids and ketones will help make that structured water, help your mitochondria create that structured water, which helps in turn keep the mitochondria themselves healthy. The wrong types of electromagnetic fields can influence structured water. So Wi-Fi and cell phone, like radiation, stuff like that, we have to be conscious of that. And then also, different toxins like glyphosate, which is, the herbicide Roundup, has actually been shown to break down fourth phase water. So lots of different things, but what we want to do to structure the water, get cold exposure, get plenty of sunlight, put your feet directly on the earth, burn the right types of fatty acids. DHA, which is only found in animal foods, is very important for that. So those types of things, that's what keeps your mitochondria healthy.
Amazing. And Dr. Hussey actually has a wonderful Instagram account, and he demonstrates all of these things he's talking about, from infrared treatment to the grounding. You do quite a lot of that too in your reels. Okay, so stress. Let's talk about stress, because no one thinks of stress as something that's healthy for us. We all know it's bad for us. It's not healthy. We want to avoid stress. But the direct link between stress and heart health was actually something new to me. So, and you bring in stories from your younger days, from your childhood. I'm going to have a heart attack. I'm so stressed. And so let's talk about stress and heart health.
Yeah. So, I think that the saying goes, like, stress kills, and it's very, very true. It's just that in our modern world, nobody really tells you how to deal with it. Stress is going to happen. It's part of life. You can't eliminate it, right? It's just going to happen. It's our ability to handle it, have an appropriate response, and go back to normal that's important. And we can get into a situation where it becomes too overwhelming for our stress response, and that's exactly what happened to me. It's one of the things that contributed to why I had a heart attack, because I was in a very stressful situation. And so there's a few things that can happen. One, there's plenty of evidence, plenty of research that shows that an acute stress drastically increases the amount of inflammation and risk of clotting. And so that's what the issue is, that clotting is what causes atherosclerosis, clotting on the lining of the artery. It's not an accumulation of cholesterol. but clotting on the lining of the artery that the body tries to repair, but also acute clots that can form that are large enough that they can block an entire artery. That's what heart attacks are. Now, those atherosclerotic areas that narrow the artery can make that more likely to happen because their artery is narrowed. But it's the stress, or stress is one of the main factors that increases these clotting factors that encourage the body to form clots. Also, lack of or poor blood flow is also another issue there. So that's one issue with stress. The other issue is that it creates this imbalance in the autonomic nervous system. And the autonomic nervous system is just the system in our body that's perceiving our environment through our senses, almost subconsciously, and telling your body, giving your body signals as if to whether you're in a safe or threatening environment. If you're in a safe environment, your body gets a signal to sleep or digest or whatever, do those types of things, detoxify. Whereas if you're in a threatening situation, your body has a stress response. And the stress response is designed to get you away from that threat or fight off and conquer that threat or whatever, eliminate the threat to your life. And so the problem with modern society is that we're the only species, humans are the only species that can literally think their way into a stress response. And our big brains have served us very, very well as far as where we've gotten to in the world. But we've developed this higher level thinking that we can think ourselves into things. And so that could be, you see something stressful happen to somebody else and there's no risk of it happening to you, or at least you have nothing in your environment that risk it happening to you, but you still fear that it happens to you. Or something stressful could happen to you. And instead of having that stress response and returning to homeostasis, you think about it the rest of the day or the rest of the week or the rest of the month, and we have all these perceived things from outside. I always think of like the dark web, all these ads for the dark web and how you're going to get caught, which may be a reality, but I think it creates this hyper fear. Or even COVID was a huge example of all this fear that was created, over this thing that was going to come get you, and fear of other people, and how they were a threat to you. It just created this fear. And so we think our way into these stress responses, and that creates this imbalance in our autonomic nervous system, and where it's not balanced signaling. Because we're supposed to be able to have a stress response, and it's supposed to be balanced out by a non-stress signal. It's always keeping itself in check. However, if we get into the states where we're chronically stressed about things, even if it's incorrectly stressed about things, like I said, we're overthinking, then we can get this state of like a surge of a stress response, and we don't get the lesser surge of a non-stress response balancing it out. And that can create a situation where we're always in this stress state and our body has no time to do anything else. So you think about it like people with insomnia or digestive issues, or sexual dysfunction, like their body's never in a rest and digest state where you can do those things, because it's always stuck in this hyperactive stress state. And so that can cause a lot of issues, especially for the heart, because the heart is the organ that perceives our emotional state and relays that state to the brain. It's why we say things like, I love you with all my heart, or we gave it all our heart, or, your heart's not in it. We have this very emotional connection to this organ because it is our sensory organ for our emotions. And there's actually more signals sent from the heart to the brain than the brain to the heart. And so because it's relaying that emotional state, and then the brain reacts accordingly, and there's actually, there's lots of nervous system signaling from the heart to the muscles of facial expression, because that's where we express our emotions. And so based on how our heart is feeling, our face is reflecting that. So yeah, this balance in the autonomic nervous system, this state of emotion, it's not just driving the stress response, but it's also what creates coherence throughout the entire body. And coherence is just the state in which, if something is in coherence, it means that it's in a state where all the different aspects or parts of the living system, the living thing, are interconnected and communicating so that they're all doing what's best for the system as a whole. And so that's coherence. And the only organ that has a high enough electromagnetic field that can touch the entire body, every cell in the body, is the heart. The heart's electromagnetic field is 5,000 times stronger than the field of the brain's. So our emotional state is what's driving this coherence of the entire body. And so if our emotional state is not being communicated well, or we're stuck in this imbalance in the autonomic nervous system, then that coherence can be interfered with. And maybe different aspects of the body are not receiving that coherent signal. And we can start to get this incoherence. And that is heavily associated with more chronic disease. And the way we measure coherence is heart rate variability. And if you look at the research with heart rate variability is literally an indicator, or poor heart rate variability, low heart rate variability is an indicator of or contributor to pretty much every chronic disease out there, because it's measuring this incoherence. The body can't link up and sync up and communicate as a whole. And so we get different tissues starting to act on their own accord, right? Rather than what's best for the whole. And so that's how the heart kind of relates to all these different things, which is why like studying the heart has taught me more about physiology in the body and how it actually works, than learning anything else anywhere. It's just like actually studying this organ. I think that, there's a reason we say like it's at the heart of the matter, because I think that we understand that the heart is what's driving most of our physiology. And so we use that metaphor as like this, this issue, this is the heart of the matter. We don't say this is the brain of the matter, even though everybody says, oh, the brain's controlling everything. Well, we say it's the heart of the matter. Why do we say that? Because we know subconsciously that the heart is what's driving, or setting the tone for coherence and proper functioning of all physiology. And that's been shown in the literature that this is what's happening. So if this organ's off, it can affect the coherence of the entire body.
Yeah, it was fascinating to read that actually you compare humans to other mammals, and other mammals in a stressful situation, say if they're facing a predator or something, or, in any stressful situation, they're stressed. And then once that situation has happened and gone and over, they completely turn off their stress signals. We humans don't do that, right? It just continues with us for years and years and years, quite often.
It can even turn up as a stored past trauma that haunts us the rest of our life if we don't process the stress and deal with it appropriately and have the correct body response. It can be something that literally stays with us for way too long. Whereas animals don't seem to have the level of thinking. And I'm sure that it may happen to them too, but not at the same level as us, because we have this level of thinking. We tend to overthink it or think our way into stress responses even when there's nothing threatening happening, whereas an animal only has it when the stress is happening. So it's interesting. And then once the stress is over, they shut down the stress response and they're back to homeostasis again. And we don't necessarily do that.
Let's talk about food for fuel. You alluded to it, obviously, that burning ketones is healthier for all our organs, particularly the heart. So what kind of a diet is best? You do cover actually Stephenson, for example, who is an anthropologist, and he lived with communities where they only eat meat and saturated fats. So you also cover, was it Weston Price research as well? So what's a good low inflammatory diet for humans?
Yeah.
The best for our heart.
Yeah. So, diet it's all full of these dogmatic camps, they're everywhere. Everybody says, oh, or not everybody, but lots of people say, oh, you should only eat plants, or you should only eat animals, you should paleo, even low carb. It's just, we can get into this dogma a little bit. And I think lower carb is better for most people, but it doesn't mean all carbs are evil. Doesn't mean that in season that humans didn't eat some carbohydrate when it was available, but it wasn't all year round, and it definitely wasn't the staple, the mainstay of their diet at all. And so, but we got to be careful not to get caught up in a certain way of eating and think that since it's best for me, then it's best for everybody, or that we need to be dogmatic about it, that we have to follow a strict set. Because I did that for years because it was, I guess, easy. If I had the strict set of rules, and I stuck to those rules, then it was easier for me to maintain a certain diet, whereas in reality, what we want a diet to do is, well, we want it to do three things. One is we want it to provide us adequate nutrients, so we want to be able to obtain the nutrients that we need, whether it's the fuel type nutrients, or it's the vitamins and minerals, then those are the important things. And then, so we need those things. We need it to create metabolic health. We need that diet to create an optimal metabolism, where the way that we break down our food is not harming us. But remember, food is only about a third of where we get our energy. So the other thing we want food to do is we want it to set us up so that we can gain energy from the rest of our environment. And so that is two of the main things that help us do that are the fatty acid DHA, which is only found in animal food, specifically seafood, or it's higher in seafood. But DHA is what literally allows us to take light from the sun and convert it to electricity so that our mitochondria can use it. And then also collagen, which is also only found in animal foods. That connective tissue protein is what our entire body is held together by. We have this fascia system within our body that's literally penetrating everything all the way down to the DNA, and all the way up to more gross structure like a bone or something, or skin. Like, it's literally holding us all together. But this fascial system is what allows us to also conduct information through it to communicate with the whole body. And so we need collagen, which is what we find in animal foods. So I think the animal foods are critical, and that maintaining low carb is, depending on the season, is also very critical, because it helps maintain our metabolism. But that's the way we should look at food. It shouldn't be this way of eating is the best, and I know it is, because it doesn't matter necessarily which way you're eating, as long as it's creating metabolic health, giving you adequate nutrients, and also setting you up to obtain nutrients from other places besides food. Those are the important things. And I think an animal-based lower carb diet is what does that the best. Doesn't mean that within our modern world, there's not other diets that could do that, other types of diets. But that one does it the best. Like a vegan diet, I think, is not going to give you the right nutrients. It's not going to give you DHA. It's not going to give you collagen. It's not going to give you a host of other things that you're going to miss out on. But the animal foods are most bioavailable. You're going to get the most nutrients from those, and then lower carb ensures that you're going to have adequate metabolic health. Those are the important things about diet. So I hope as long as you get that, whatever you're eating, if it helps you do those things, then there you go. I guess the other aspect is you also want to make sure that your diet is not exposing you to toxins, right? So you don't want to be eating these processed foods that have been sprayed with all these chemicals, and different plant toxins can be an issue too. So you want to make sure that your food is also not creating a negative situation or doing a negative thing. You want it to only be doing those positive things, and make sure it does all those positive things.
I loved your story of when you were working in Dublin, Ireland, and you were a vegan at the time, or maybe vegetarian. Oh no, vegan. I think you were vegan, and then you were served this soup, and there was butter on the table, and you added butter to the soup, and felt better, and then you added more, and you felt better. I like that. So what do you think you were missing, your body was missing on a vegan diet? Because I also transitioned only 2 years ago from vegetarian, vegan diet to eating meat, as well as some vegetables, but I definitely thriving on a meat-based diet, although meat isn't the only thing I eat, but meat-based diet is like predominantly animal foods. I'm thriving on that diet.
Yeah, I mean, I always tried to be healthy. This was like, when I was in Ireland, that was almost 10 years ago now. And that's when I kind of switched over, because I had been vegan for a little while, and thinking I was doing what's best for my health. And And I think that the main thing I was missing was just the correct type of fats for my brain, and for I was depriving my body of the ability to take energy from the sun and convert it into energy for me. And so, but I think that was the main thing. And so I was kind of starving my brain a little bit, because when I started, well, first of all, I had that experience where someone offered me some butter, and I had some, and then I wanted more. And then I went to the store and I bought a chicken, and before I even realized it, I ate the whole thing. And I was just like, it's kind of like I had a moment where I was just like, well, I really want these things, and lots of vegans will shame you for it. Like, oh, you can't control your urges or something. It's just like, no, your body's saying it wants this, And so, and I think it was because I just, for a long time, hadn't had adequate amounts of the right types of fatty acids. And because what I noticed over the next few months as I started eating more and more animal foods was that my brain, I felt like it just was on fire in a good way, like not an inflammatory way, but like on fire, and like it was just functioning like crazy. Like I was, I was just reading things and just being able to remember them better and connect it up with other things I've read and just put things together. It was really the start of like my work, and like how I, started researching and reading and being able to put it all together into these books and things. It was like, that's what started it, was my ability to do that again. So I think the main thing I was missing was the fatty acids. But then blood sugar became a lot easier to control as well, and I stopped getting a cold every few months, and lots of different things happened that I would describe as good or positive things. But it's still though, like even just changing the diet, and that's my big thing, is that I would try and put forth in the book, is that heart disease is not just about diet. It's a small part of what can contribute to heart disease, but it's not the driver of heart disease whatsoever, in my opinion. And there's so many different other things, because this false theory about cholesterol and saturated fat that came about, and heart disease was blamed for those things, because that was a kind of a dietary thing. We found saturated fat and cholesterol within foods that we eat. Then the conversation about heart disease became all about food. And it had to be, the way you prevent it had to be about food. And that can be a contributor to the systemic process that is heart disease, but it's only a small contributor, in my opinion. There's many, many other things that we should be doing, as far as our environment, that can contribute, or, to heart disease or create health. So
how about salt in the diet? Because of course, the understanding is that too much salt will raise your blood pressure, and higher blood pressure will lead almost definitely to heart attack. You've got a whole chapter, maybe even 2 chapters on blood pressure, explaining blood pressure and the role of the heart in regulating blood pressure. Let's talk about that.
Yeah. So the idea that salt causes high blood pressure, it's just because, when the body has low salt, it tries to hold on to as much salt as it can. So that happens in the kidneys. As the kidneys are filtering the blood, if there's not enough salt, they're trying to hold on to salt. Now, salt, these minerals, have to be dissolved in water. And so in order to hold on to that salt, you hold on to water too. And so if you hold on to water, the thought was that was creating higher blood pressure, because there's more volume of fluid in the system, it creates more pressure in the tubes, right? And so so they were thinking that, oh, the salt is causing this, when in reality it's the fact that you have too little salt that is causing your body to hold on to the salt, and then therefore hold on to the water, right? So if we give ourselves adequate salt, then the body's like, oh, we don't have to hold on to as much salt, we can let it go along with the fluid, right? And so then that will lower the blood pressure, which is exactly how some blood pressure medicines work. They actually trigger that system to flush out the fluid. They stop the holding on of it. So, but in reality, we're so deprived of the actual salts that we need. And then back in the day, we would have gotten lots of salts because the meat that we were eating was a little more bloody than it is today. They hang it today and let all the blood drain out as much as it can, where back in the day, we would have been eating a little more of that blood, which contains all the minerals. And so minerals are incredibly important for that. But there's actually, there's evidence that having too little salt and too little electrolytes actually creates a situation where you can create insulin resistance, which is a big marker or a big risk factor for high blood pressure, insulin resistance. So being low in salt actually can create high blood pressure in many different ways. I just described two of them. But also the most important thing about salt is that the heart, it doesn't just deliver the cardiovascular system doesn't just deliver nutrients through blood, whether it's fatty acids or vitamins, minerals, or whatever it may be. It doesn't just deliver those through blood. It also conducts electricity and magnetism through the blood itself. And what makes the water so conductive is the electrolytes, is the salt in the blood. That's what makes it very conductive. And so if we don't have enough of that, we're not getting as conductive of a signal through the fluid of the blood, the water in the blood. So that's very important as well. But yeah, it's just big miss. And there's actually studies where they showed that if they gave some people a diuretic, and then if they gave them a diuretic with salt or with the saline solution, that it was more effective. Because if you gave people salt, it said, oh, we have enough salt, we can let go of more. We can let go of more salt, therefore letting go of more fluid. And so it makes no sense that people are being told not to eat salt. And that's exactly what I was told in the hospital whenever I had a heart attack was, here's a low salt diet. We got to prevent heart failure. And I knew that to be absolutely false. And I told them, I said, this is the diet that creates heart failure or creates high blood pressure. And they were just like, no, that's not what the research says. And I was like, okay, I'm not going to eat that way. So yeah, but that's a big misconception as well.
Right. So that's salt covered. You do actually talk about, people who want to avoid fish or who want to avoid red meat. Now, people who want to avoid red meat, they usually give those two sort of reasons. One is the TMAO, which we only recently started hearing about. That wasn't even a thing. So now there are days when it's actually trending on Google. So the TMAO, and you do cover it in the book, and of course mTOR. So TMAO, for those of you who haven't heard it, it's trimethylamine N oxide. So hopefully Dr. Hussey can tell us more about it. And is it dangerous to health? So should we really worry about it? And does meat or fish contain more TMAO?
Fish actually does, which is why it's so contradictory that they're saying, oh, TMAO causes heart disease, because they're saying, oh, but fish is so good for you, red meat's not. And fish actually, and it's not that it necessarily has more, it's just that it tells your body to create more. But the thing is, and we have to step back and we have to like my answer to this question is a philosophical one. And I have a very technical answer to the mTOR question, but it's the same philosophical approach. We've gotten so bogged down in biochemistry and it's like this reductionist way of thinking, this like these linear systems, like this happens, then this happens, and this happens, we get disease. And that's just not how any complex biological ecosystem works. It doesn't work like that at all. There's many, last time I checked, I'm not exposed to one thing at one time. I'm exposed to many different things all at the same time. And so how can we ever expect to study this one molecule, TMAO, and say, yes, this is the driver of disease or a contributor to disease, right? It just doesn't make sense. It's the same thing as LDL. How can we study this one thing and say, oh, this molecule is literally driving a whole disease process? Makes no sense whatsoever, because there's so many different moving parts and so many different reactions happening all at the same time. There's so many different things affecting my body all at the same time. So it's a very reductionist way of thinking, and it's a fear tactic, right? It's by the people that want us to think that meat is bad for us. They try and isolate these one things, and they show in a petri dish that maybe it caused some damage to a cell, which also makes no sense, because that cell is not in the body anymore. How do we expect it to behave like it would in the body in its ecosystem? So it's a very flawed way of looking at physiology, but it's also incredibly short-sighted to think that one molecule in the body can drive an entire disease process or even contribute to it, right? We have to look at our entire state. We have to look at the body as a whole. right? We're trying to get narrower and narrower focus, and reductionist, more reductionist, trying to identify the biochemistry of a certain disease process. And the way that the reason that is because the pharmaceutical companies are the ones that are driving the research. And if you can show that this one biochemical pathway is creating disease and they can make a drug to affect that biochemical pathway, they make a lot of money. That's exactly what happened with statin drugs. It's what happened with all kinds of things. And so that's how the research is, like that's the way it's designed. And like in research, you're trying to eliminate all the variables, but to me, that is completely ridiculous because humans are never exposed to one variable at a time. So how can you really say that that's anything or that means anything? So that's kind of the spiel on all these little different, like even U5GC and MTOR and TMAO, like all these different things. They're just all trying to say that meat causes them and that contributes to disease, but they're really just trying to frame the meat. And if you look at all these studies, they're all funded by the grain industry or the sugar industry or whoever, the plant-based meat industry and whatever. So anyways, and then with MTOR is mammalian targeted rapamycin, and it's basically a kind of a trigger for growth and repair. And so they're thinking, oh yeah, if you have a lot of MTOR, you're going to get too much growth. That's cancer. We don't want that abnormal growth, right? Which is completely not true. I mean, maybe it is in the long run, but there's a lot of things that have to go wrong for cancer. So it's not just, higher MTOR. But the issue with it is that they say that meat raises MTOR, and it does. That's what you want when you eat. You want to trigger growth and repair. You want to fix things. You want to grow muscle. You want to do that kind of stuff. That's exactly what you want to happen. The thing is that so the two things that trigger MTOR are insulin and leucine, the amino acid leucine. So meat has high in leucine, right? So it's going to trigger MTOR production and the raising of MTOR, but so is insulin, right? So the difference is that when you trigger mTOR with amino acid leucine, it does so for a shorter amount of time. I think it's like 30 minutes to an hour, something like that. Pretty short time. And that you get that growth and repair signal, and then it goes away, right? Whereas if you trigger it with insulin, so if you're eating a high carb processed food diet and you trigger insulin production, you're going to trigger mTOR, and it lasts for 3-4 hours. And the other thing is that when you eat a high carb processed food diet, you're going to be less satiated. And so you're going to eat again in 3 or 4 hours, and you're going to trigger it again. And then you're going to eat again in 3 or 4 hours, you're going to trigger it again. And so you end up having mTOR all day long. So is the problem the meat that triggers mTOR in a normal physiologic way, or is it the high insulin levels that most people are having because of their standard American diets, right? That's having mTOR triggered all day long, rather than just a few hours, maybe twice a day. So that's the issue there, and that's it. But I hope that what people take home from that is not that mTOR is fine. It's just that it's the flawed way of looking at biochemistry, which I don't think that hyper analyzing biochemistry and doing all this medical research based on biochemistry is really going to get us the answers to how to be healthy. It's just going to drive a fear-based pharmaceutical, a fear system, a fear-based supplement system, a fear-based food system. It's driving all this fear to try to encourage us to go one direction when really we shouldn't be. So.
Did you say insulin turns off, high insulin levels turn on mTOR?
Yeah.
Interesting. Yeah.
Mm-hmm.
And this is why insulin resistance, you do cover it in the book as well, is an important marker of, overall metabolic health, but also heart health. So let's talk about the insulin resistance.
Yeah.
How does it impact heart health?
The main way is that, it leads to two different things. One is that, if you're insulin resistant, your blood sugars are going to be higher, and higher blood sugars especially fluctuating higher blood sugars, can lead to more oxidative stress and inflammation that damage the lining of the artery. But the main way that insulin resistance contributes to heart disease in the sense of atherosclerosis is that insulin is a signal or can signal for growth and repair. And so if there's damage to the lining of the artery, they're supposed to be able to repair themselves. I mean, there's always going to be normal wear and tear to the artery because things are flowing, there's shear stress, and that's just normal. Just like in your car, there's going to be wear and tear, right? But we're supposed to be able to repair itself within a timely manner. However, if we're insulin resistant and that cell, the endothelial cell, never gets the signal to repair, then the damage stays there too long and the body has to do something else. It has to form clotting tissue on it to repair that damage. Because if it doesn't, then the artery could start bleeding from the artery wall itself, which lead to a rupture, which is way more problematic short term than clotting tissue on the lining of an artery that stabilizes it. And sometimes that clotting tissue has cholesterol in it because when it clots, cholesterol just happens to be around and it gets caught up in the thing. But there's no, like when you look at atherosclerosis, it's like 80 to 90% clotting tissue. There's really very little, if any, cholesterol in it. And so that's the big player there, but it all has to do with insulin resistance. Like that's why there's such a heavy association with diabetes, which is insulin resistance, and atherosclerosis, because these people have lost the ability to signal for repair through insulin signaling, and that leads to the body having to do something else to repair that, which is, clotting tissue, which is kind of like this spackle that patches it up, But that's the main thing. And then long-term insulin resistance is, if we get more systemic insulin resistance, we get fluctuating blood sugars, which lead to all kinds of damage to vascular tissue, to small capillaries. So that's why diabetics get issues with circulation in the feet, with their eyes, with kidneys, things like that.
Next is fiber. So we're told fiber is protective of heart health. Mm-hmm. Do we have evidence for it?
No, there's really no evidence that fiber is protective for heart health at all. And these are Cochrane database studies, which is very kind of, I guess it's the most free, I guess, of bias from, or of influence from different industry and things like that. But doesn't mean it's not free of it, but it's the least affected by it. But yeah, so if we look at all those studies, there's really no evidence that fiber is protective for heart health, or that fiber is necessary really for proper digestion or anything like that. Your body will, like, it all talks about like fiber and how important it is for like the gut bacteria and everything, but your body will burn, the gut bacteria will feed off of different amino acids rather than fiber if you remove fiber. And there's actually studies that show that if you remove fiber, you relieve constipation and things like that. So it's all about, how your body transitions from going to that fiber. And I'm not going to say that fiber is this evil thing that's causing harm. There is some evidence that it can interfere with nutrient absorption. But I think that the main issue is that people are eating way too much fiber, because we're told to take these fiber supplements and take these prebiotic fibers and to eat all these grains and eat all these fruits and vegetables. And we're just told to eat and eat and eat all this fiber. And I don't think, fiber it's indigestible, it's insoluble, it just creates bulk. So you poop a lot, and then people are like, oh, look how good it's working. It's like, no, you're just pooping out stuff your body couldn't use. That's why you're pooping so much, right? And so if you remove that, then it stops interfering with nutrient absorption, and your body will adjust, and your digestion is fine. And then there's no evidence that it prevents heart disease either. So it's really not that important of a nutrient as we're told. So, and at least definitely not in the amounts that we're told to eat it.
And may I just add here that I know a lot of my followers are low carbers, that a lot of low carbohydrate processed foods, from cookies to protein bars, etc., actually contain fiber from different plants, just the fiber part. So I know from personal experience, they completely wreck my gut. I just can't tolerate them at all.
Yeah. There's actually a diet. I can't remember what it's called exactly, but it was basically, it's basically removing fiber. And this was back in the 70s. Some ladies, figured it out, And it's been around since then too, or before then too. But I remember like when I was in college discovering this diet that was just like this lady was removing fiber and relieving all people's gut stuff. So it's been around for a while.
Now we're talking about gut health. How does it relate? How does it even link or connect to heart health?
Yeah, so the gut is the other organ that we sometimes associate with our emotional state. We have gut feelings about things,
Mm-hmm.
that kind of stuff, or we get like stressed and our gut gets all messed up. We get that kind of stuff. So it's definitely connects to our emotional state. So it plays a role in signaling for balance in the autonomic nervous system. So it's very important there. So the state of our gut is, so it's kind of like the gut is kind of like an external environment that's inside our body because it's supposed to be at least sealed off all the way through. So if you think about it, we're kind of like a donut, and where it's got this tube going through, and then so that's kind of a link to what our external environment is like. It's one way that our body senses our external environment by what's coming in and going through the tube, right? And so if it's in a state of inflammation and it's not functioning properly, that can definitely signal to the body that we should be in a stress state, which will then in turn affect the heart because of the imbalance signaling in the autonomic nervous system and how the heart is especially perceptive of that. So yeah, that's good gut health is important for helping maintain balance in the autonomic nervous system, but also for because some of those bacteria produce different nutrients to help us with detoxification and just getting certain B vitamins and things like that. So important for that aspect of things as well.
And it's a similar story with oral health, right?
Mm-hmm. Yeah, the health of our mouth is very important. If we don't have good dental health, we can get things like the main issue is endotoxemia, which is the same with gut. If we don't have good gut health, then we have leaky gut, then that bacteria can leak into the bloodstream that shouldn't be there. It's the same with the mouth. We have like gingivitis, or we have a root canal, or we have a tooth that's been pulled and wasn't cleaned out properly, then that can leave us a situation where there's bacteria that are not supposed to be in the blood that are leaking into the bloodstream. And the body goes to attack those bacteria and kill them, and that releases endotoxins. So we get this endotoxemia, which is very heavily associated, like higher levels of endotoxins in the blood is very heavily associated with higher levels of atherosclerosis because they're very damaging. Anything that damages the lining of the artery is going to be linked with higher levels of atherosclerosis. And so the health of the gut and the mouth are very important as far as preventing endotoxemia.
Okay, so other things which are protective of your heart are obviously the collagen, which you did mention earlier on. But there are other nutrients as well, which only come from animal foods. And you list those. So there's carnitine, taurine, and creatine, right?
Mm-hmm.
Very
Yes.
important.
Yeah, very, very important for heart health. I mean, creatine itself helps maintain the function of the heart muscle, which the heart is a muscle. So we want adequate function and contracting of that muscle. Taurine is very important for healing the lining of the artery, and taurine we get in high amounts in things like pork and also like sardines are very high in taurine, and then and not really found in plant foods that much. And then carnosine is very important for healing the heart muscle too, and helping create a high functioning heart muscle. And then carnitine is probably the most important because carnitine is what allows us to use or to take fatty acids and allow the mitochondria to use them to burn for fuel. So that's very important as far as like mitochondrial health, which is very important for the heart because it's the highest of mitochondria. But carnitine has also been shown so there's a study they did where they induced a heart attack in rats. And then they used carnitine to prevent damage during reperfusion, which is when, because part of the heart muscle had lost blood supply for a while, and when they reperfused it, when they put blood back into that area, sometimes it can create some damage because it's just kind of an intense, stressful situation for the heart. But if they use carnitine, it prevented that damage during reperfusion. So it prevented scarring and damage, or I guess long-term damage, because it prevented scarring of the heart tissue itself. So carnitine, incredibly important. So it's one of the main things I did, because I started taking a supplement of carnitine. I'd rather get it from food. I think that's always better. But after my heart attack, I wanted to, get a little bit more. So I supplemented with a little bit so that I could help prevent this deposition of scar tissue in my heart. And that's, I think that's what attributed to the fact that I don't have any scarring or less conduction of signal in my heart.
So one other thing related to diet is, of course, the vegetable oils. So seed oil. So we're talking about corn oil, sunflower oil, etc., and heart health.
Yeah.
What evidence do we have?
The main issue with those is that they seem to break your metabolism, or at least they don't help your metabolism. So if you're trying to burn these polyunsaturated fats, which is what vegetable oils are, then it actually doesn't trigger satiation very well. And so you can keep eating them and keep eating them and keep eating them, and you get too many calories. And so that's one issue with them, is that they seem to contribute to insulin resistance by breaking the mitochondria. And then the other issue is that they're very highly oxidized. They're very damaged, or they're easily damaged, which is why, as soon as you take them out of, the chemical process they use to make them, and they put them in light environments or heat environments, they become very oxidized and damaged, and those are very inflammatory. And so that can lead to damage to the lining of the artery. It can damage the mitochondria. It could just create this state of overall inflammation. And polyunsaturated fats, we need some of them, and their job is to, like, during an inflammatory process, help with that inflammatory process. That's why, a steak has the right amount of polyunsaturated fats for us. If we overeat those polyunsaturated fats, then we get an issue with inducing too much inflammation, because our body is having to use those polyunsaturated fats to build up, our cell membranes and things like that, and that leads to the state of just enhanced inflammation when we do have an inflammatory response. And then the final issue with the polyunsaturated fats is that they're from plant fats. There's this whole philosophy of plant fats versus animal fats, and we talk about phytosterol is what plants use. That's plant fat. And cholesterol is what animals use, and we're animals, so we use cholesterol. But we can use phytosterol if in a pinch, if we need to. We can use it to do certain things, but it's not as good for us. And so the main example is that it can get deposited around the heart valves. We have evidence for that, this phytosterol, so it can kind of clog up heart valves and make the valves go bad. And then the other thing is that if your body uses phytosterol to make in the structure of red blood cells, it actually makes them very rigid, so that they can't bend very well. And so then when they're trying to go through these very small capillaries, they can't flex and bend to fit through them very well. And that can lead to, or predispose us to, things like stroke, because it damages the very small arteries. And so we want those nice flexible red blood cells, and we need to make them of cholesterol, not phytosterol.
Fascinating. One last question that related. I don't think it was in the book, but talking about fish, for example, how worried would you be? I mean, you're trained in functional medicine as well. So how worried are you about mercury?
Yeah, I definitely worry about it. And the way to protect yourself from that is, first of all, limit your exposure to heavy metals and from other things, whether that's aluminum foils or cadmium from cigarette smoke, or different places where we get arsenic from rice and in the soils and things like that. But also, eat fish that are lower on the food chain, that have accumulated less mercury. That's the kind of the solution there. So for some reason, salmon seem to hold less mercury, but also smaller fish like sardines and anchovies and things like that tend to have way less mercury. So I eat a can of sardines most days, not every day, but yeah, so eating those, and then also upping your detoxification pathways, so making sure we're sweating as often as we can, like getting the heavy metals out, and making sure that your liver is supported, and those heavy metal detoxification pathways are helping getting the metals out. So that's, having enough sulfur, which, you get from seafood and eggs and things like that, but also the right types of amino acids. So from collagen is really important. So, it has a different set of amino acids that are helpful for the sulfonation of those heavy metals, so that your liver can extract them and get them out through detoxification pathways. So that's the signal. That's the solution to those heavy metals. Eating less of them by fish lower on the food chain, and then supporting detoxification.
So we covered the eating part quite extensively. I think my audience would agree here.
Yeah.
Well, how about not eating, fasting? I think you do cover fasting as well in the book. So how important is it for heart health?
Yeah, I think that it's a strategy that can be used. There's definitely a lot of evidence that fasting will help with cardiometabolic risk factors. Again, those aren't the end all be all as far as assessing your risk of heart disease, but there's a lot of evidence there. I think it makes sense that there were times when humans, weren't constantly eating all day long, and this idea of 3 meals a day has definitely been marketed by the food industry very heavily. I think that, and I've actually, I used to think that, just an 8-hour window, no matter when it was, or an 8 to 10 hour window, no matter when it was useful. I think that the morning is better, like eating earlier in the day and not eating later in the day, especially 3 to 4 hours before bed, just because of what it, as far as our natural circadian rhythm and how that helps with it. So I think that eating, within 30 minutes to an hour of waking is very useful, and then cutting your eating window off, 3 to 4 hours before bed is probably the best strategy. But yeah, fasting definitely makes sense from an evolutionary perspective. It's shown to have plenty of benefits. And there's some studies that show that even if you don't change what you're eating, if you just change when you're eating and you restrict the time, then you get the same benefits as if you changed what you ate. So I think still what you eat is very important too, but it's just interesting that the timing is also very important.
Stephen, let's talk about something that you call dopamine fast.
Yeah.
In the book, that was completely new to me, and I was fascinated by it. And it makes sense. Why do we need to take a break from the constant dopamine release? And how does it protect our heart?
Yes, dopamine is just this molecule that's secreted, kind of, it's like the reward kind of signal for your brain. So we get a little surge of dopamine every time we check something off a list, or every time we check our phones, check an email, or it's kind of like this little satisfaction thing. However, in today's society, I think that marketing companies, they know this type of thing, and so they put a lot of things in front of our face. They get us almost addicted to this dopamine surge, and when that happens, we just want more and more and more of it, and that can lead to this imbalance in the autonomic nervous system, because we're constantly seeking that surge of dopamine, and so what can be very useful is this thing that I heard of called dopamine fasting, where you literally go and you remove all sources of these surges of dopamine. So that means you're not eating, because that will surge dopamine. It means you're not watching TV, you're not reading, you're not talking to anybody. Literally what I do is I try and just go sit in the woods for as long as I can. And so some people do it for, half a day or a whole day. You just, if you can carve time out of your schedule to do that, then do that. But it could also be as simple as like doing an hour in like these sensory deprivation tanks, they have, where they have one here in my town where you can go and it's just like dark in there and you're floating in this high salt water. So you're just floating in the tub on your back, and it's dark, and you don't hear anything, you don't see anything, you don't really feel anything because you're floating in water. And it's really like this sensory deprivation. So it's removing this all these dopamine surges. So things like that can be incredibly useful. as far as, maintaining balance in our autonomic nervous system.
Are supplements important for heart health? Okay. In fact, not just supplements, but particularly vitamin D and K2, but also aspirin. If blood clots is a problem, then aspirin is a blood thinner. Are you in favor of that?
Right. So, well, aspirin first. So aspirin is, it's a blood thinner because it shuts down the healing process. So like if you get an injury and you want something to heal, then that's the COX signaling pathway is what will do that. And aspirin will shut that down. And so which will, inhibit a pain signal, it will shut down the inflammation and things like that. And so it will also thin the blood. And so that's what it's used for, or supposedly used for. However, there's no really evidence that a baby aspirin is preventative for a primary heart attack, so a first-time heart attack. There is some evidence that it's useful for prevention of a secondary heart attack, like people's second heart attacks, but I think there's much better ways to induce or to create adequate flow of blood and adequate viscosity of blood than taking an aspirin, because we don't want to shut down that healing pathway, that growth and repair pathway that it does shut down. So things like sunlight and grounding are how we increase blood flow and decrease blood viscosity. Those things are really important. Also, magnesium is very important. So yeah, that can be accomplished those ways without the negative side effects of aspirin, because aspirin, long-term use of it, has also been heavily associated with bleeding, like GI bleeding and things like that. And then vitamin D, I don't really think supplementing with it has shown much benefit. Very few times does it actually increase vitamin D levels. It can be anti-inflammatory just because when you're taking it, but it doesn't really increase the body's amount of it. Right. So in order to get the right increase vitamin D, you have to be in the sun, and you also have to have adequate cholesterol levels and adequate sulfur, because those are the things that the backbones of vitamin D. So you have to have those things with adequate sunlight, and that's what will raise your vitamin D levels, and that's the best way to get it to, because there's so many other benefits of getting sunlight. And then vitamin K2, really, really important for prevention of calcification of the lining of the arteries. But also bone health, because it's what takes vitamin K2 is what's responsible for taking the minerals and depositing where they need to go, like in the teeth and the bones and things like that. It's what Weston Price named the X factor, or vitamin X, or whatever he called it, but he didn't know it was K2 at the time. But that's what these tribes of people that he was studying were so keen on getting, is this K2. But actually, statins can actually interfere with that process. But K2, you're going to find in high amounts in animal foods. So that's the most important way to get them, is in things like liver and egg yolks and butter and grass-fed butter and things like that. Like, we want to get high amounts that way and rely on supplements as little as possible, because they're synthetic vitamins and minerals. They're taken out of isolation food. We just don't know how well we're absorbing them, and they could also be in different forms. So always try and get as much as you can from food. But yeah, all those nutrients are important, but the way that we get them is also important as well.
Excellent. We're going to finish it off, Dr. Hussey, but why don't we tell our audience what tests would be useful for them? I mean, some would be covered by insurance in the United States, for example, and some of those tests are not covered here by our NHS, by the way, and I know because I've checked them out. But what tests would be important for people to follow their heart health?
I mean, I have a certain set of tests that I guess people could kind of get, but I don't like people to get into the weeds about testing. I don't think that we should dictate whether we're healthy or not, or we're at risk for something by any one test, because if you look at the research, these risk factors that we attribute to assessing for heart disease risk don't predict heart disease. They just don't. Doesn't mean that you can't take them and gain information from them. Doesn't mean I don't look at testing with my clients and stuff. But we have to take it with a grain of salt, and we have to take it within the context of the person as a whole. But generally, you want to measure metabolic health, which is a trig to HDL ratio, which you can get on a lipid panel, and then fasting insulin level. Those are the two best indicators of how metabolic healthy we are. But also a leptin level could be very useful, because leptin resistance is what precedes insulin resistance. So that could be a really early sign of if things are going awry. And then you can measure inflammation and oxidative stress. So inflammation, you can measure, which is HSCRP, just a general marker of inflammation. And, oxidative stress, you can measure with a liver GGT. And those things could give you a good indication. But you could get into the weeds measuring those things. You can measure all kinds of stuff, but it's like, I'd rather you spend your money on other things, because whether or not these tests are high, it doesn't matter. The solution to bringing them down or keeping them normal, if they're normal, is the same thing. So just go and do those things. And then heart rate variability is also, I think, a useful thing to be tracking. And there's various devices you can use to track heart rate variability. Everything from it's Apple Watches or the Oura Ring or different things like that. You can use to track that, because that gives you that measure of balance in the autonomic nervous system and coherence of the body, which are the real telltale signs of whether or not you're going to, have some disease process whatsoever.
And the coronary artery calcium score, is that important?
I mean, it can give you, I did a video on this recently, and it can give you an indication of how healthy your arteries have been over your lifetime, but it's not really a direct indicator of how at risk you are for a heart attack right now, because it gives you no information about inflammation or oxidative stress. It gives you no information about insulin resistance. It gives you no information about heart rate variability or balance in the autonomic nervous system. All it's doing is measuring if there's calcium in your coronary arteries. So I don't think it's the best test for measuring risk in the moment.
What a wonderful conversation this has been. I could easily talk to you for another hour, Dr. Hussey, but I've got to leave you to start your day. I'm sure you've got patients waiting for you today. So thank you so much. And we're going to do this again. I'm sure my audience will love you. We're going to do this again, but this time Dr. Hussey and I will talk type 1 diabetes, and only type 1 diabetes. So thank you so much for your time today. I really appreciate it.
Of course, yeah, happy to be here. Hopefully people enjoy it.
Thank you very much. Bye for now.
Bye-bye.